Good morning. My name is Tianshu. I came from China. I am working at North China Electrical Power University, and my topic is the dynamic behavior of PMU and the latest development in China. First, I'd like to introduce the power grid in China. This is a schematic diagram of Chinese power grid. There are totally 7 regional power grids: Northeast China, North China, Central China, Northwest, East, South China, and Tibet. Right now, it's an interconnected power grid. And North China and Central China by AC link, others by DC. And for this interconnected power grids, of course, PMU measurements is crucial for dynamic monitoring and also security analysis and control. Here is the history of PMUs in China. GPS has been introduced to Chinese power grid since 1993, and synchronized phasor measurement techniques have attracted increasingly interest since the middle of 1990s. And Chinese APRI attempts to introduce this is a one kind of fault recorder with a GPS from Taiwan to China during 1996 to 1998. Since 2002, Chinese manufacturers have their own PMUs, and right now some of them began to explore the overseas market. And here, there are 2 types of PMU in China. One PMU, like the United States, is for substation. The other type is for generation. They'd like to equip a sensor at the shaft of the generator and can measure the internal voltage angle directly. And there are totally 4 manufacturers for PMU. They are Beijing Sifang Automation Company and also Chinese APRI, Nanri Technology Development Co. Limited, and also Nanri Relay. And here is the application history of WAMS and PMU in China. Since 2002, WAMS was put into operation in North China Power Grid Dispatching Center. And after that, several events really push the application of PMU. The first one is about the dynamic model parameter. Here means in 2004, 2 man-made short-circuit experiment was done in Northeast China Power Grid. At that time, 2 experiments, 3 phase short circuit was made at 500 kV substation at Northeast China Power Grid. And before the experiment, by simulation, we can see that the phase angle between the Northeast China Power Grid and also the North China, the phase angle will be estimated as 20 degrees. But after the man-made short circuit by Synchrophasor data, the actual phase angle only 7 degrees. So we can see only by simulation there is a totally different result from the actual measurements. So that's one driving factor. And after that, because around that time, the Chinese power grid began to interconnected, but the interconnection between grids is really weak. So low frequency oscillation is really severe for Chinese power grid. And at that time, PMU is the only tool available for monitoring low frequency oscillations. And the third one is about in 2006, there is a contingency or blackout in Central China Power Grid. For that contingency, half of Zhengzhou City, the capital of Herman province, experienced a blackout. And for that contingency, of course, the data was recorded by synchrophasor measurements. So after 2006, PMU really developed very fast in Chinese power grid. So right now, the total numbers of PMU commissioned in Chinese power grid is about 2,500, and cover all the 500 kV substations, 100 megawatt generators, and also some important 220 kV substations. And also PMU might go into 110 voltage level substations, maybe in the near future. And here are PMU applications. First, of course, real-time dynamic status monitoring and alarming processing, and also model validation and parameter identification. Of course, PMU dynamic behavior testing and calibration, and also state estimation with PMU measurements, and also wide area protection against cascading trips, low frequency oscillation identification and control. We got much involved in the application studies. When we did such kind of research work, we can find that the PMU measurements from the practical power grid is not as ideal as we imagined. So we try to study the PMU characteristic and also do some testing and validation work. So I came to the PMU standards in China. In 2003, the first standard about the PMU was released in China. And then in 2005, this standard was revised, and PMU performance and data transformation format were specified in details. After that, in 2011, a new standard specification was released, and the dynamic standard specification were specified in this new standard. But you know, we did the PMU dynamic test in our lab. Here I show some results. This work was done by last year. And here the 4 PMU manufacturers, their products. And the first one is about the static test. And when the frequency changes from 45 Hertz to 55 Hertz, we can see this is the voltage magnitude error. And this is the Chinese specification. Is the error should lower than 0.2%. And we can see that the static performance is really good for PMU. But it's different for dynamic condition. We can see this is the magnitude modulation test. When we change the modulation frequency from 0 to 5 Hertz, we can see with the modulation frequency go up, the error also go up greatly. And this is about the frequency modulation test. And again, we can see the similar phenomenon. This 0.002 Hertz is the requirement in the standard. Also for the step test, here we can see the PMU 1, 2, 3, 4, and of course the PMU 1 and the PMU 4 behaves not so good. And this infinite because the PMU measurements cannot go into the error limit after the step change. So that's why here is the infinite. But after our test, we give feedback to all the manufacturers in China, and they try to improve their products. I believe right now their behavior should be much better than the results I showed here. Here is about the ramp of frequency test. And actually in Chinese standard, there is no requirement about the behavior at the condition of ramp of frequency test. So that's why, you know, the behaviors behave not so good. And according to the algorithm analysis and the PMU performance test results, right now the Chinese PMU standards are under revision, and cooperated with a state grid company, the formal PMU test of all PMUs from Chinese manufacturers, maybe also from overseas, will be implemented from June 15th until July 15th, which we hope by this formal test we can really provide a solid basis for the PMU applications and promote the PMU technology. Next, of course, the activities with Professor Phadke and Jim Thorp. I think I want to introduce their work in China. Of course, we got to know because of the CRIS, and here are 5 CRIS conferences, international conference, and among them, the conference 2002 and 2010 were held in China. And also, we got a 111 project from Chinese government. This is a project aiming at solving the problems for China by international expertise. So our topic is about wide area protection and control for interconnected power grids. And we really did a lot of work by this project, and just because of their very good, excellent contributions, the project already passed the assessment of the first stage, the first 5 years. And right now, very fortunately, we got the second stage support, another 5-year financial support, starting from this year, 2013. And also, we have several workshops on PMU and its applications. Professor Phadke, Jim Thorp, and also Ken Martin, contribute a lot about the PMU standards and also applications, suggestions, comments for Chinese power industry. And also, this is a letter, congratulatory letter from Professor Qixun Yang, another old friend of Phadke and also Professor Jim Thorp. I tried to find a picture for that 375 babies last year, but I cannot find it. So finally, I put this picture here. I want to say, conveying Professor Yang's greeting, the warmest and most sincere congratulations on your careers with remarkable contributions to the power industry. I want to say not only for the United States, but also for China. Thank you very much.